Welcome back to Divine Inspired Care. So glad you could join us again. Have you ever questioned why diabetes is frequently labeled as a silent murderer? This illness is truly perplexing, a medical mystery renowned for its covert onset. It doesn't declare its presence with a dramatic array of symptoms. Instead, it secretly and gradually infiltrates. Its lethality isn't just due to the silent way it establishes itself in your body, but also the complex system it employs. A system so elaborate it confounds even the most experienced medical professionals. In this, we'll delve deeper into the sinister world of diabetes, illuminating its clinical progression. We will scrutinize the crucial roles that two hormones, insulin and glucagon, play in the diabetes storyline. We'll then decipher the maze-like processes that underlie the two main variants of this disease, type 1 and type 2 diabetes, each having its own unique pathophysiology and clinical presentation. We will enlighten you on the intricate progression of diabetes, focusing on the roles of two key hormones, insulin and glucagon, and the distinct processes implicated in type 1 and type 2 diabetes. The human body, in its remarkable complexity, maintains glucose levels in the blood relative to cellular glucose uptake through the actions of insulin and glucagon. These actions are nothing short of a biological balancing act. Insulin and glucagon are the main characters in this play, produced by the pancreas, one of the body's most vital organs. The pancreas is like the conductor of the body's metabolic orchestra, ensuring harmony and balance. Located within the pancreas are specialized cells aptly named islets of Langerhans. These islands are home to the alpha and beta cells responsible for producing glucagon and insulin. These cells are named after the Greek letters alpha and beta, showing the universal language of science at play. In this specialized cellular arena, insulin, secreted by beta cells, plays a critical. Think of insulin as the body's helpful delivery service, transporting glucose to where it's needed most, our tissues, including muscle and fat cells. Insulin acts as a key that unlocks the doors of the cells, allowing glucose to enter and be used as fuel. Its function is to lower blood glucose levels, ensuring we don't experience the harmful effects of too much sugar in the bloodstream. On the other side of the spectrum, glucagon, released by alpha cells, is the counterbalance. Glucagon is like the body's emergency reserve, stepping in to raise blood glucose levels when they plummet too low. It prompts the liver to generate more glucose and also starts the process of breaking down glycogen into glucose. This push and pull, this balancing act, is crucial to our body's survival. On the flip side, glucagon, released by alpha cells, raises blood glucose levels by stimulating the liver to generate glucose and by breaking down glycogen into glucose. Diabetes mellitus disrupts the delicate balance of our bodily functions. It does this through two principal culprits, type 1 and type 2 diabetes, each with its distinct way of wreaking havoc in our bodies. For now, let's focus on type 1 diabetes and how it meddles with our physiological processes. Type 1 diabetes, unlike its counterpart, is characterized by a noteworthy deficiency in insulin production. This deficiency is not a simple malfunction, rather it's an intricate issue rooted in our immune system. The problem arises from a cell-mediated immune response, wherein the body's own T cells mistakenly launch an attack on the beta cells within the pancreas. The beta cells are crucial, for they are the insulin factories of our body. In one diabetic scenario, these factories are under siege, leading to a significant shortfall in insulin production. The aftermath is an elevation in blood glucose levels as insulin, the key hormone responsible for regulating blood sugar levels, is in short supply. This unfortunate chain of events is not random but often associated with specific genetic factors. Two genes are particularly notorious in this regard, the HLA-DR3 and HLA-DR4. They are believed to increase the susceptibility to type 1 diabetes, marking a significant turning point in our understanding of this disease. This process is often associated with specific genetic factors, such as the HLA-DR3 and HLA-DR4 genes. In type 1 diabetes, the destruction of beta cells, which are the cells in the pancreas that make insulin, often starts early in life. This early onset, however, is not instantly noticeable because the symptoms only begin to show after a substantial number of beta cells have been eliminated. It's an insidious process that sneaks up on the individual, making its presence known only when the damage has reached a significant level. The first noticeable symptoms are usually related to the body's inability to effectively use glucose, the primary source of energy for cells. This includes an in-hunger, which in the medical world is known as polyphagia. The hungry cells demand more fuel to function, but without the necessary insulin to facilitate glucose uptake, they are left deprived and starving. This is where the increased hunger originates. Moreover, as the body struggles to manage its energy resources, it is not uncommon to see glucose in the urine, a condition medically referred to as glucosuria. This happens because the kidneys, which filter our blood, become overwhelmed by the high levels of glucose and start to excrete some of it in urine. This also explains the frequency of urination, also known as polyuria. The body's reaction to these changes isn't limited to just increased hunger and urination. There's also an increase in thirst or polydipsia. This heightened thirst comes as a direct result of the increase in urination. As glucose spills over into the urine, it pulls water from the body along with it, leads to dehydration, hence the increased thirst. These are the body's responses to its inability to access glucose for energy, leading to the breakdown of fat and muscle tissues and increased hunger. Additionally, high glucose levels in the blood cause glucose to spill into the urine, drawing water with it and ultimately resulting in increased urination and thirst. This sets off a chain reaction within the body, with one symptom leading to another, in a cascading sequence of events that underscores the complexity of this disease. One serious complication of type 1 diabetes is diabetic ketoacidosis. This particular condition is more than just a symptom. It is a dangerous and potentially lethal outcome of the disease. It happens when the body finds itself incapable of utilizing glucose effectively for energy. Typically, glucose, the body's preferred source of fuel, is employed to keep our systems running smoothly. However, in patients with type 1 diabetes, the intricate system that regulates glucose utilization malfunctions. Insulin, the hormone responsible for helping our cells absorb glucose, is either absent or drastically reduced in these individuals. Without insulin, glucose piles up in the bloodstream and the cells are starved for fuel. In a desperate attempt to find a substitute energy source, the body begins to break down fat. This process results in the production of ketone bodies, a type of acid that the body can use as a makeshift fuel. However, when produced in large amounts, these ketones can lead to a dangerous condition known as acidosis, which can harm various organs and systems. This is where the term diabetic ketoacidosis comes from. It is a condition that requires swift medical attention and a careful adjustment of insulin levels to ensure the patient's safety. And thus, diabetic ketoacidosis occurs when the body, unable to use glucose for energy, starts breaking down fat into ketone bodies, leading to a potentially life-threatening condition. In summary, diabetes is a multifaceted disorder characterized by the body's inability to balance blood glucose levels effectively. Diabetes is a pervasive disease that affects millions of individuals worldwide, and its prevalence continues to rise at alarming rates. The core problem associated with diabetes is the body's inability to regulate glucose, the main type of sugar in the blood. Understanding diabetes begins with a comprehension of the physiological roles of insulin and glucagon. Insulin and glucagon are hormones produced by the pancreas, working in tandem to regulate blood sugar levels. Insulin lowers blood glucose levels by enabling cells to absorb glucose from the bloodstream, whereas glucagon raises blood glucose levels by stimulating the liver to release stored glucose. The intricate balance between these two hormones is critical for maintaining optimum blood glucose levels. Moreover, it is imperative to recognize the distinct pathophysiological mechanisms underlying type 1 and type 2 diabetes. Type 1 diabetes, also known as insulin-dependent diabetes, is usually diagnosed in children and young adults. It involves an autoimmune reaction, where the body's immune system attacks the insulin-producing cells in the pancreas. On other hand, type 2 diabetes often develops later in life and is characterized by the body's resistance to insulin, meaning it cannot use insulin properly, leading to chronic high blood sugar levels. Becoming informed and knowledgeable about diabetes is crucial. It is not merely about knowing the facts, but understanding the impact and implications of the disease. Awareness and understanding are the first steps towards management and control of this chronic condition.